In this video, you're going to learn about how to sample stormwaters, how to handle them, including how to store them, how to process the samples so that you minimize the error in concentrations. So first thing you have to remember that most of the time the monitoring is very expensive. So because it requires manual labors, it also time sensitive. Whenever there is rainfall events, you go out there and take samples. So it's very critical for you to remember what are the different factors that could influence the concentration of pollutants in stormwater when you take samples them. And also a lot of times, they are not being, a lot of times you have to remember that green infrastructures are not monitored. When you design a green infrastructures, it's monitored for a year or two because of this expense. So now let's see, when you measure the concentrations of pollutants in stormwater at location outside, remember that these stormwater concentrations can vary very widely. And the reason is just the nature of how pollutants are released from environments during rainfall. So for instance, here it is you can see that there is these figures that explain what that means. Based on rainfall, imagine the rainfall started, this is the let's say rainfall. Just a simplicity, this is the volume of water that dropped, let's say 1 inch, and it's being rain for this much time, and then it stopped. So this is, let's say, rainfall or the hydrograph. We can call this as hydrograph. That's basically the patterns of rainfall. And the response of hydrograph or rainfall is basically runoff. And the runoff, the volume at any locations over time in response to rainfall is called hydrograph. This is basically runoff volume or flow rate or discharge rate at any times. Okay. And so what you can see that in response to that, you may see that that will change as time progresses. The flow rate increases. At some point, the flow rate will diminish because there is not enough rainwater coming anymore. So it diminishes to the background level. And so this is a change in flow rate at different times, or discharge rate at different times is called hydrograph. This hydrograph is a function of land use, size of catchment. We are going to learn that. So again, hydrograph is basically the how quickly water moves, and this is called peak flow. And this peak flow will determine whether the stormwater infrastructure is able to discharge all that water without having to have flooding. And for the pollutant concentration at different locations, if you take pollutant concentration at different times and you predict or you measure them, you might see something like this. So this is called pollutant concentrations or discharge rate, or the pollutant mass discharge per unit time. So this is again the flux of pollutants. And so you might find that pollutant concentrations can vary. First thing what you realize here is that pollutant concentration can vary at different times when you take samples. So imagine if you go to a locations and you decided that somebody asks you a question, what is the concentrations of pollutant in stormwater in these rainfall events? If you take samples here, you get a different number. If you take sample here, you get a different number. If you take sample here, you get a different numbers. So based on when and where you take samples, that could vary a lot. So that's why a lot of times when we measure the concentration, we do not call one concentrations. We may have to report everything, and but that's not desirable. So that time, what we call is the event mean concentration. That means you have to normalize for the entire concentrations as a function of the volume of water discharged. So that's what we call event mean concentrations, and where that's basically what that means is if you add them all the mass of pollutants discharged in that time, a mass of pollutants by volume of water discharge. And mass of pollutants is basically concentrations time volume. Concentrations time volume of pollutants. And concentrations, you report this concentration, and volume you don't directly measure because flowing, but you measure the flow rate at different time. So that means you multiply volume of water volume of water times time, you'll get the volume of water. And so that's basically the mass of pollutants. And so if you take at different times, different fractions, then this you can get this value. And now if you're looking at the total volume of water is basically is a um, you can calculate that volume of water, yeah. So that's what we are doing. So now if you are looking for event wind concentrations, you are basically calculating the entire fraction into that volume. So let's say that means you calculate that value. So this is a volume is a here is a there is an error here. And if you're looking at a volume at different fractions, you know the volume flow rate. So Q time dt is going to delta T will give you the volume at any times if you're measuring, and if you're adding all the volumes, then you are getting entire volume. So event band concentrations, EMC, is basically mass per volume, mass of pollutants at different samples. Let's say take 10 samples at different times, and each sample has certain volumes. So different times difference. So you calculate the concentrations and Q delta T, that will give you the total mass. And this is number of samples you take at different times. And this is volume is Q dt. Okay. So that's how we can calculate. And so this is all that means is if you take different samples, you calculate the mass of pollutants. EMC is the mass of pollutant for different samples. I is the number of samples by volume of samples for different times if you add them together at different occasions, different times. So now mass is basically concentrations times volume by total volume. And then that volume is basically, if you don't know the volume, you can calculate Q times delta T. The flow rate change, as you see in the hydrograph, the flow rate also changed. So that means you can calculate those flow rate at different times. So at different times, the flow rate and concentrations, if you have those knowledge, you will be able to predict that value. So for instance, here, it's the example is given in the book. The table below gives the concentration of TSS runoff from a campus parking lot. Find the total TS mass and EMC for the storm events. So what you do is you know the flow rates. So that means you have a TSS milligram per liter. So because of time, you can calculate the delta T. So delta T is going to be between 10 to 11. So this is 1 hour. So this is 60 minutes. This is 60 minutes, 60 minutes. So this is all 60 minutes. Or if you calculate hours. And if you see that second, so this is flow rate in seconds. So that means if you, this is the flow rate that happens before that. So for this one, you can calculate Q, delta C, QC, and delta T. So that's basically 0. That's a 0. So this is 0. Now this is basically 175 milligram per liter times this is a 2. The flow rate is 2.8 liter per second. So you can assume that this is the flow rate, and the time is basically 60 minutes. So 60 minutes is a 60 times 60 second. So when you put that one, you get a numbers, little cancel, you get a number in milligram. You calculate that for each one in milligram. So this is in milligram. And then you add them all together, you get a total amount, total TSS in milligram. So this is the amount of water the pollutants you get TSS mass. And then it says what is the event mean concentrations. So how do you calculate event mean concentration? So again, total mass by total volume. So you can take the entire mass, which is basically this, by total volume. If you know the difference how much volume you calculate. So then you'll be able to predict. So how do you calculate volume, total volume? Again, let me write it here. Amount of water, delta V in this time. If you multiply Q time delta T, you'll get the amount of volume you calculate. So this is 2.8 times 60, 2.8 liter per second. Here you have 60 minutes, so that means 60 times 60. If you multiply that, that's the amount of water that has discharged. So same thing, you calculate 4.9 times 3600. 4.9 times 3600. Same thing, you do all of them. And then add them all together. Volume would be delta V of all. That will get you in liter. So now you have total mass. So event mean concentrations is total mass by total volume discharged. So you get the total volume, you get the total mass, you will be able to calculate event means concentrations.